Okay, shall I start? Hello. Yeah. Yeah. Hi everyone. This is Sai Kiran. Today we are going to learn about what is Helm. So before knowing about what exactly Helm is, you need to have some idea on what exactly Kubernetes is. So basically, Kubernetes is an open source orchestration platform, which allows you to automate many of the manual processes like deploying, managing, and scaling up the containerized applications. So you have a question like what exactly containerized applications means, right? So let me walk you through in this way. Say let's say for example, uh, when we have a application like .NET or any other application. So when it comes towards one of the DevOps engineer, what he will do? So first he will dockerize the image. Image means application. So the Dockerizing means you know exactly what Docker means, right? Like Docker is a popular containerization technology, so which helps you to package all your application and its dependencies and put it as a simple and lightweight and portable container. Let's say container. The application that you have, the .NET application, is now converted into the containerized application. That is what we can do with the Docker. So with the help of Docker, we're building the application in the form of simple and lightweighted and portable container, right? So now the next step is to deploy it into the Kubernetes. So to deploy it into the why Kubernetes, like earlier I said, like Kubernetes help us to automate all the manual process like deploying, managing, and scaling up the containerized application. That containerized application is nothing but your .NET application now. So um, you you have a question like where we exactly put our containerized applications in Kubernetes, right? So in Kubernetes cluster we have a concept called pods. So in pods, pod is the you need to know about the pod. Right? Pod is nothing but a simple smallest deployment unit in Kubernetes, and the pod holds your containerized application. So that containerized application has been put in the pod, and the pod has been placed in the Kubernetes cluster. That's how you deploy. Next, if you want to run your application in the browser after you deploy it into the Kubernetes, then you need to have a dedicated IP address, right? So you to run the application in the browser. So for that you need to have a service. So here by going forward according to the requirement, the number of files has been increasing, right? To deploy the container application into the Kubernetes, you need a pod. So you need to create one pod file, and then you need to create a service and you need to create a dedicated IP address, right? So for that you need to create a service, and then one deployment file. Like according to the requirement, the number of files has been increasing, right? So for that, um, let's say all the files that you have configured has been created in a language called YAML. YAML is nothing but a ain't markup language. It is also a markup language, which is in the form of human data, human readable data format. So that is, it doesn't matter which developer you are. For example, you are a Java developer, Python developer. It doesn't matter. If you look the YAML file, it is understandable and it is easy to read. Okay, and you will understand the process of what going on. So Kubernetes decide to use that kind of language to deploy the containerized applications into the Kubernetes. Okay. Now we have the pod, we have the service, everything in the Kubernetes. So this is where Helm comes into the picture. It will let me show you that. Yeah, I forgot to share the presentation. Yeah, sorry. Okay, this is at the time, like it will bundle up all the YAML files into one. With the help of Helm, it will install all the YAML files that you created for for deploying the container application into the Kubernetes. So like you created a pod.yaml, you created a like service.yaml, and also you need to create a deployment file for the whole containerized application into the pod, and then you need to create a one replica. See, that bundle of YAML files has been packaged into the one and maintained by one um, template. So that's why that's where Helm comes into the picture. So that's how Helm will help in Kubernetes to deploy the container images into the container applications into the Kubernetes. Okay, that's where Helm will help you. And the second thing, like let's see the structure of Helm, how the structure looks like. If let's try with the manual implementation, like how we create a Helm. Okay, let's go to Visual Studio. You need to install the Helm. Okay, with the I will send you the link of how we install the Helm. Okay, later this session you can play with the Helm. Okay, now you need to first before installing the Helm, you need to create a Helm, like Helm create. Let's say it's sales is the name of the file, so it is created here, right? So whatever you have seen here, so here you have seen the structure of the Helm, right? So it is the tree structure of the Helm. So whatever you have seen here, it is exactly shown like this. Like by default, it will be creating like this. Like we are having the charts, templates, and values.yml. So these are the three main components in Helm that will help you to deploy your applications into the Kubernetes. Like for example, the main and foremost thing is chart.yml. That with the help of chart.yml, it is nothing but the chart.yml contains the unique name which is going to represent your whole Helm. This whole Helm charts and whole values.yml. This with the help of let's say if you want to run this command like Helm install, you need to pass the chart name here like sales, and you need to give the one release name. Okay, so that's how it's helpful. Like, so this chart name will going to it will going to execute all your files in the template. So I will tell you what exactly template means also. Template is like for example, in a real-time scenario, like take an example of photo editing apps like Pixart, Adobe Lightroom, or else any photo director, any app. Like there you can see n number of templates like birthday wishes or else wedding anniversary. Like the templates are same for everyone. Like the templates are same. It will be shown for everyone in the same way. But what you have to do is you have to put your own image, whomsoever you want to send, right? That's how you are designing the templates. You are designing the YAMLs in Helm. It is in such a way that is helpful to everyone in your community, in your organization. For example, you design the YAML in such a way that is helpful to your organization. What if the same configuration has been wanted by some other organization? Like for example, I'm from CSI. You are from some other organization like Equifax. We are having the same requirement. So there is no need to create another deployment file. There is no need to create another ingress.yml. No need to create. Just you download my YAMLs and put it on your Helm. That will automatically install all your help. That's how it helps. So let's see what values.yml means. So here let's take one example of service.yml. Here you can see how I pass the values, like in dot values dot service dot type, I parameterize the whole YAML file and given the value from the external file. The external file is none other than the values.yml. Here you can see the values you want to the configuration values you want to send. Like I said, I show you the type of the service. Like I'm sending the type as cluster IP. Right here, that cluster IP has been provided here, right here, by parameterizing the value of service type. Okay, that's how every file has been every file has been designed. Like it is parameterized and is helpful in across every organization. It is helpful. Like that is the difference between using the normal Kubernetes YAMLs and using the global templates that is designed by the Helm. So yeah, let's see. Let's create one. Okay, earlier I said like uh, you put the containerized application in Kubernetes cluster inside a pod, right? So you got me right. So that pod and service, the pod need to have one service to run it on the URL, and and the pod need to have a one deployment YAML, everything, right? So for that you need to have a space for your own space. Like inside the cluster you need to have some space for you. So for example, it is nothing like a, we are calling it as a namespace. We are creating a space for your own okay, inside the cluster. That means you are creating a virtual cluster inside the, okay, inside a Kubernetes cluster. Let's create first a namespace like Kubernetes. Let's give it as a sales namespace. Okay. Okay. Sorry.
kubectl.
Yeah. Sorry. Here kubectl is the command line interface for the Kubernetes. Like it is the command line. I mean, like for the Windows we have the command prompt, right? Like for the Kubernetes we have the kubectl. So here you see the sales namespace has been created. Like if you see in the, not here. Let me show you here. Okay, here you can see there is no namespace is created earlier. So I created namespace now. So let's see, is it visible in the namespace folder like resources? So here there is the namespace, right? Now you need to deploy all your YAMLs into the namespace. So what you have to do is you need to configure your files. Like you need to put EF service account services, all of them in the. Okay, give whatever required as of now, like sending the pod into the namespace service, as that's it. Okay, I'm telling the basics of how we are using it. Okay, and give it in the pod as well. The deployment as well. So here I'm passing like dot values dot namespace, right? So what I need to do is I need to give the value of namespace right here in the values.yml. See, so like namespace. Okay. 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 Let's put it on the front side, on the top side. Let's whatever we have created, like sales namespace. Earlier, let's see if you see kubectl get all -n sales namespace. This command helps you to see whatever there in your namespace. Okay. So here you can see there are no such resources have been there in the inside your namespace, right? So let's save it. Okay. Let's save and run with the help of Helm. How you can achieve this with the help of Helm means with the help of Helm install command, and give one release name. So it Helm will generate a unique release name that will help you to release upgrade your Helm and roll back your Helm, and it. Okay. So the error is like namespaces is not found. Now it get deployed. Now you see whether the sales namespace has any resources have been there, like pod and services on the deployment and replica sets. There you can see this is your container application. So you are deployed into the pod. Okay, that is up and running, and you have a dedicated IP address to it. So now if you want to uh, run it on the browser, what you need to do is you need to put the service as load balancer, which helps you to generate an IP, generate a external IP address. Here, type as load balancer. Put type as load balancer and run it. So if you want to run with the internal cluster IP, see if you run it on the URL. It will not going to work. Okay, let's put the type as a load balancer and make sure the external IP has been exposed. So now let's run. So now there is no need to uninstall the things that you have created. So you just need to use the upgrade command in Helm. So Helm upgrade hyphen install, and with the help of let's 1 minute, we need to know the release. With the help of Helm ls, you can have the all the releases that you have. So let's the help of Helm upgrade, you can upgrade our Helm charts. This is my release name, this is my chart name. Okay, I'm upgrading the whatever I previously installed. I'm just upgrading my install. Okay, with the unique chart name and the release name. Now see what have been there in kubectl. Get ns, get all, hyphen n, namespace is right, sales namespace, right? See here the external IP has been exposed. Okay, with the help of this you are able to run it on the, so this one is not running right. See now the page has been displayed, like this is the image that we sent from Helm. So I will show you that as well. So uh, we are sending the Nginx image, right? So whatever the image that you created, like the .NET application that you created, that has been that has been built by the Docker, that the containerized application has been given right here as a repository name. Okay, that's how it will help us, like it will bundle up all the YAML files and package them into one, and it will deploy the, see if you see, like the service has been, the service, the deployment, that pod, everything has been installed at once, right? There is no like kubectl apply if and f1 giving the pod.yaml, and not kubectl apply if and f1 giving the dedicated service to it. So that is not up to mark. Like Helm is help us to package all of things. Okay, and then next it will design it is designed in such a way that we can use the templates that we are created, like these YAMLs that are created in such a way that are helpful to each and everyone in our community. Like if you want to use these template, you can use it. There is no like my project values. Okay, it is global. So that's how Helm will work. And next, see, I already explained you about the Helm. Like if you deploy the pod in a release, see here release A and release B means, like um, for example, I have a release A as a dev and release B as QA. So both of them having the same configuration, right? In dev, we are testing the environment, testing the application. In release B, we are having the QA part. So for the QA, for the dev, both of them we are deploying the same application, right? So then there is no need to create a separate folder for QA and separate YAMLs for QA. There is no need. The YAMLs are same, but you need to change the namespace name and deploy them. That's it. So that's where Helm will help us in the day-to-day life. So now I will show you how exactly the Helm looks like in the Azure pipelines. You all know that what exactly Azure pipelines means, right? It is in the screen, like automation is the future. This is what exactly Azure DevOps will do. It will automate automate your application to test uh, in two ways, like CA and CD. So continuous integration and continuous deployment. So for the continuous integration, in continuous integration, we do uh, building and testing in continuous integration. So it will enhance your application. And for example, you are developing a code and you have some errors at the initial stage of your development. The pipeline show you the uh, error with a more appropriate answer. So it will help you to fix that bugs in a easier way, and it is very feasible to use. So that's where CI continuous integration will help. So continuous delivery means it is the delivery process, right? So for example, you say if you take any hackathon exam, like you need to pass each and every test case, right, in order to score 50 marks, right? So the same Azure pipeline release pipeline put set of policies to you. So you need to maintain that policies and make sure that you will run the pipeline in such a way that uh, satisfy that policies. So in deliveries also we have a different set of environments like dev, QA, UAT, prod. According to the requirement, you deliver the application into respect to environment. So that's how it works. Let me show you how exactly we are doing Helm. Here deploying Helm. We are deploying containerized applications to Kubernetes with the help of Helm. Let me show you that. So here, the pipeline, if you go to the pipeline section in Azure DevOps, it will look like this. Let's open any of the pipeline, create a new pipeline. Okay, create a new pipeline. Azure DevOps, pick the Azure DevOps, and next take. I'm using the AKS core services right now. So let's use the starter pipeline. So here you need to add the task right here. Here you have a predefined task right here in the Azure DevOps pipeline. Likewise, the Helm is also there. So here you can see the Helm. Here you need to put the respective uh, subscription that you have. Here you need to give the resource group. There is no resource group in this. Wait. Okay. See, you need to put the Kubernetes cluster, like cluster name. Okay. You send the, if you want to send the namespace, send the namespace. Here you see whatever I install, like if I install the Helm, here is the command. If you want to install with the chart name, you can install with the chart name. If you want to install with the file path, like file path looks exactly like this. Like if you have, if it is like you install the chart, right? So this is the chart path. This is you can see right here, sales DM 100 desktop sales chart.yml. This is the path. Like in pipelines.yml in Azure DevOps, I design Helm in such a way. Okay, I will take this and send it here. Okay, that's how it works. Once you add it, this is exactly how the Helm deployed your containerized application into the Kubernetes. That's how it helps in pipeline. Okay. Uh, That's it, Sandhya.
Okay. Are you done with the session?
I think I'm so fast.
That's okay, fine. So if anybody wants to ask him any questions, I guess he's open for it.
You can ask anything.
Karthik, do you want to ask any questions to him?
No, actually, I will shoot out daily a couple of questions to him. So, okay. So, Sai, is there any difference? Like in Terraform Cloud, we do have workspaces, right? So here you mentioned the namespace. So is it similar kind like namespace versus Terraform workspace? Is it similar or like is it different concept?
Uh, Terraform is a different concept, like it is a infrastructure level, right? So Kubernetes will give like it, it will give you the like namespace is nothing but a virtual cluster that has been designed inside the cluster. So one is the infrastructure and one is like application layer mode, like.
Yeah. Thanks.
Anybody else? Ram?